Hello everyone. In this video I'm going to show you how to categorize your effect sizes by different outcome coding to organize your effect sizes and combine like measures within a study. This will allow you to compare similar measures as a composite between studies. In case a certain type of measure is reported in different ways within a study, you can create a variable that'll combine all of those measures into one composite measure. So I'm going to show you what I'm talking about here. We're going to open up the effect size calculator, and I've already entered the data from the study we'll be using, which is right here, and it's also available for download within the video description. And I also have this EScodes file, which is one of our categorizations for measures, for our effect size measures, and I'll show you that as well. So here's our study. And here's our effect size code. So I'm going to explain all this right now. So the best way to show you is we're going to open up the effect size calculator here, and we're going to open up the study. In this study there's an intervention and control group. So just one intervention and one control group, which is why I left this column blank. You can enter intervention versus control if you'd like, but typically if there's only one intervention group and a control group, then I just leave that column blank because it's pretty much assumed that you're comparing the intervention to the control group. So scrolling down here, we're going to look at this table right here. So as you can see, this top group is the intervention group, this bottom group is the control group. And we have baseline data, immediate post-test, 6-month, and 12-month. So looking at our designs, we're going to be using design 1 here, which is 2-group pre-test post-test design, given that there is 2 groups that we're comparing and there's pre-test and post-test data at immediate post-test, 6-month, and 12-month. So the measures we're going to look at are right here. So as you can see, these measures are all very similar, yet they're reported in different ways. This first measure is proportion of condom protected sex as a mean standard deviation. This second one is consistent 100% condom use, and this is reported actually as a percentage. And unprotected sex, so sex without a condom, and this is reported as a mean standard deviation. So what we have is 3 measures that are very similar in what they're trying to convey, but they're separate measures and they're being reported in different ways. So what we want to do with our effect size is we want to create a variable that combines all 3 of these to represent condom use or protected sex in general, and that will incorporate all 3 different ways of reporting the measure. So looking at this file that I opened up before, we have different categorization schemes for all of our variables. These top highlighted rows are psychological variables. Here we have behavioral variables. And here down here we have biological variables. This is just one of our many coding schemes. You tend to create your coding scheme based on what you want to look at within your meta-analysis and also what you're seeing in the literature as you go through and do your effect sizes. So you may notice things are being reported in a certain way, and it makes sense to report and combine in a certain way for measures, for similar measures. So outcome is this column I was referring to in previous videos. This is the column we've been leaving blank because we didn't know how we were going to categorize effect sizes. So given that we have 3 measures here, proportion of condom protected sex, consistent condom use 100% of the time, and unprotected sex, we're going to say that we want to combine all of those 3 measures to represent a condom use measure. So we want them all to be represented by one composite measure for condom use. So if you look here, all of these variables and variable labels are going to represent the different ways within this coding scheme that we categorize condom use. So this 15, 15A, 15B, 15C is going to represent reported condom use with casual partners, with steady partner, with unspecified partner. Some measures are more specific. They may report anal sex with casual, steady, or unspecified, or may report vaginal sex with casual, steady, or unspecified. So given that we look at these measures here and they don't specify any of them, whether it's anal sex or vaginal sex, it's looking at either kind of sex, we can eliminate these as coding options. So it's reported condom use for unspecified sex, composite. So looking at all three measures again, it doesn't mention casual partner in any of these measures, so we're going to eliminate that as an option. It doesn't mention steady partner, so we're going to eliminate that as an option. So we're going to actually pick 15C to represent unspecified partner. So what we have here is 15C reported condom use for unspecified partner is what we're going to categorize these measures as. So we're going to create a composite measure of reported condom use with an unspecified partner denoted by 15C. So what's going to go in this column is 15C for all of these variables. So now we have a categorization scheme that we can put across all of our studies within our meta, where we're categorizing condom use measures or unprotected sex measures with unspecified partners and unspecified type of sex will be categorized within each study as 15C. So now what we're going to want to do is we're going to want to combine the measures, and we're going to want to do it at each time point. So you can see here it's separated right now by each measure, post, 24 week, 48 week for each one. So we're going to want to organize it so that we can combine each measure, all three measures at each time point. So for example, we're going to move this row up here. We're going to move this row up here. So now we'll combine these three to create our 15C variable at post test. We'll combine these three to have our combined composite 15C variable at 24 week. And we'll do the same here for 48 week. So scrolling right as well, you can see how we have reversed these effect sizes. If you haven't watched the video on reversing effect sizes, you should watch that before you watch this video. This is why it's important to get all your effect sizes in the same direction, because when you combine like measures, you're going to want them all to be intuitively facing the same direction. So a positive number in the effect size for the experimental group, you're going to want to say whether it improved the desirable outcome towards the desirable outcome, or if it moved in an undesirable direction. Control, the same thing, pre-post in this effect size. And then experimental versus control, a positive value indicating benefits more for the experimental group versus the control, and a negative indicating the control moved in a more desirable outcome than the experimental. So looking quickly, you can see in all three of these effect sizes here, there is improvement in all the outcomes. So improved proportion of condom protected sex, increased consistent condom use, and decreased unprotected sex. And you can see the same here as well. within all of these three variables, and then you can see within these three variables that they're all positive, and that indicates that the experimental group was more effective than the control group. And that can be understood quickly by looking here at the experimental and the control again, seeing that the experimental values are more positive than the control values. So what we're going to do now is we're going to create a new row for each of the composite variables for each time point. So this is going to be our post-test row for 15C, 24 week for 15C, 48 week for 15C. You can copy this author info down. You're going to copy the follow-up in weeks. So this is going to be our post-test 15C variable, since it's combining these. 24 week, 48 week. We're leaving this measure cell blank because it's being reported as all different measures, so there's no particular measure title. It's just the outcome categorization, which we have here. So we're going to label these. Each composite variable is 15C. For economy use, unspecified sex, unspecified partner. You can leave all this blank. You're going to want to put in the post-test sample size for the experimental and the post-test sample size for the control. So 232, 212, 209. Something like this pops up on your screen, you can just delete these. 235, 221, 229. So once again, these shouldn't be popping up, but in case your workbook is formatted that it is, you can just delete those. And the last thing I'm going to have you do is you're going to create an equation, this total n column. You're going to take the post-test n experimental group, and you're going to add that to the post-test n and the control group. And you're going to copy and paste that equation for all the variables you're combining. So what we're going to want to do now at each time point for each of these three variables, we're going to want to combine the three measures at that time point to give us effect size data here. That's going to combine all the information up here from the three measures, and it's going to give us our composite information and our composite effect size data. So the big thing that's important here is the sample sizes that are being reported for your measures. So in this particular case, you can see here that the post-test of the experimental at each time point and the post-test for the control each time point, for each particular time point, that sample size is the same. So you have 235 here for each, 221 here for this time point, 229, and the same thing for the experimental group. So each of these effect sizes is going to be weighted the same. So you can see that reflected here as well in the total n. In certain cases, there's going to be times when these n's are actually different at experimental post-test and control post-test for each measure. So when that's the case, you're going to want to weigh each measure, each individual measure by their sample size, so that when you have your composite measure, you're taking more into account the measure with the larger sample size than you are the measure with the smaller sample size, which makes sense because you're going to want to give more weight based on how many people answer that question. If only 10 people answered a question at post-test, you're not going to want to give that same weight to the measure where there's 100 people that answered it. So you're going to want your effect size data, the composite variable, to reflect the sample size within each measure. So in this case, the total n, the control post-test n, and the experimental post-test n, they're all identical. So in these instances, for example, to get an effect size, you can just divide these three variables by 3 to get an average. So this would be your average effect size for experimental pre-post, given that the sample size is the same for each one. This 232 is the same for each one. You don't have to weigh the effect size here, But if these were different sample sizes, you would have to weigh that effect size. So I'm going to show you how to give a weight to each measure based on the sample size. Even though these sample sizes are identical, I'm going to show you the equations to use and the way to calculate, assuming that they were different. So typically, given that these are the same, you wouldn't calculate it this way. You would just do the average of the three as I just did. But I'm going to show you how you multiply and take into account the sample sizes of each measure. So this is the effect size experimental pre-post. So this corresponds to the sample size of post-test of the experimental. This is the effect size of the control pre-post, so it's going to correspond to the control post-test sample size. And this is the effect size experimental versus control. And seeing as it's using both the experimental control group, it's corresponding to this sample size here. So what we're going to do is we're going to put an equation in here. And what we're going to want to do is we're going to look at this first measure. We're going to take this effect size and we're going to multiply it by the post-test sample size for that measure and put that equation in parentheses. Now you're going to add it to another equation. That equation is going to be this next measure multiplied by the post-test sample size of that measure for the experimental group. And you're going to add another equation in parentheses. That's going to be this third measure, our final measure, multiplied by the sample size for the experimental post-test. This is the experimental pre-post effect size. Now if you had more measures that you were combining, you would do that until you've gone through and multiplied each measure within parentheses by its sample size, experimental post-test. We've covered all three measures here, so we're going to put parentheses around that entire equation. And then what you're going to want to do is you're going to want to sum by the sample size of each equation. So you're going to want to sum the three sample sizes we used here for each of the equations, for each of the measures. So what you have essentially is the effect size times the sample size post-test for the experimental group at each measure and summing them, and then you're dividing by the sample sizes at post-test added up for each measure. And what that's going to give you here is what would be a weighted effect size. If you recall, when I divided the summation of these three effect sizes by 3, it gave the same number, and that's because these sample sizes are the same. If they were different, then you wouldn't get two identical numbers there. So now we're going to want to do the same thing for the variance. Instead of re-entering the data or re-entering the equations, you can copy and paste the equation we just did over into this variance cell. And you're going to want to do the same thing. And basically how you're going to do that is you're going to be multiplying now the variance in each measure by its sample size to weight each variance by the sample size. And you're going to sum those, and then you're going to divide by the total sample size. So you can copy and paste that equation that you just used over into the cell I just showed, and then you just drag these sample size cells to be highlighted over the sample sizes you wanted again. So now it's doing the same thing. If you look up here in the formula bar, it's multiplying this variance by this sample size, this variance by this sample size, this variance by this sample size. It's summing them, and then it's dividing them by the summation of these three sample sizes. Okay, enter there. The weight is going to be the same thing. As you copy and paste the equation, obviously it's just moving these cells over here over to the right. So all you're doing is moving them back to highlight the cells they're supposed to be highlighting. So you're moving them back over the experimental post-test cells. So once again, the weight is now being multiplied here by this measure's post-test, here by this measure's post-test, here by this measure's post-test, summing them all and dividing by the sum of the sample sizes. And you're going to do the same thing for the confidence interval. Just copy and paste and then drag these cells over. This is being weighted again by the sample size. And this is as well. So that's going to give you all your composite information for your experimental variable, for your composite variable, pre-post. Now we're going to want to do the control variable. You're not going to copy and paste anything from these cells. You're going to create a new equation for this D. And it's going to be the same idea. You're going to take this effect size here for this measure, but instead of the experimental post-test, you're going to multiply by the control post-test sample size. You're going to add that to the multiplication of this D by this sample size for this measure. And the same for this third one. You're going to put parentheses around this equation. And then you're going to divide by the sum of the sample sizes that you used again. So that's going to give you your average effect size there for the composite variable. And just like we did for the experimental group, for the control group, you can copy and paste this data over, and you can drag these sample size cells to cover the sample size again, seeing as they move to the right. You're going to keep doing that through the confidence intervals for the control group. Now your control data is complete. And now we're going to look here at the experimental versus control data. And you're doing the same thing, except now instead of using the experimental post-test or the control post-test, you're using this total N that we did over here, that we calculated. So we're going to multiply this effect size by this total N here. Add that to this effect size times this total N here. And finally, add it to this effect size and this total N here. Put parentheses around this equation, this group of equations, and you're going to divide by the sum of the sample sizes you used, which in this case were the total N's. And that's going to be your average effect size, experimental versus control. And once again, for this, you can copy through and just make sure you move these cells back to where they should be, which is over the sample size columns. And now you've completed your effect size for the experimental versus control data for the composite variable. So going through this row, you have the post-test 15C composite variable. That's combining all three of these measures that are being categorized as condom use or protected sex for unspecified sex and unspecified partner. You have post-test sample size reported here. And here you have your composite effect size information for the experimental pre-post with your effect size here. The composite information for the control with the effect size here. And the composite information for the experimental versus the control with the effect size here. So now looking down here, you can see that we're combining in a similar fashion for these measures. You're still looking at three measures, and you're still looking at effect size for the experimental group, effect size for the control group, and effect size for the experimental versus control group. So given that there's 3 measures you're combining and it's using the same comparisons for experimental pre-post, control pre-post, and experimental versus control pre-post, your equations are all going to be the same for when you combine. So you can copy and paste all these equations you just did for your composite variable into these cells for the next time points. So just clicking through quickly, you can see the equations match up the same. Multiplying here by the sample size here, this D by the sample size here, this D by the sample size here. You're summing those equations and then you're dividing by this total sample size, and clicking on another random one, you can see again it's multiplying by the total n's and then it's dividing by the sum of the sample sizes. So that's going to give you a way to combine variables in a way that when you do your final analysis, you can combine like measures and compare like measures and do your final analysis for combined measures instead of having to separately do an analysis of separate measures that are inherently similar in many ways.